Right, we'll look at the following. So, we want to express the cos of 75 degrees in third form without using a calculator. So, we look at our table. What is the problem? These might have been at the end of the homework last week, but I didn't get a chance to cover them. What is the problem, guys? There's no 75 degrees. So this is something known as a compound angle. So we have to use two angles that we have to somehow get, what did I say, 75 is it? Yeah, to somehow get 75 degrees. So, which two angles do you think we're going to use? Exactly, 30 and 45, man, 30 and 45. So we're going to use the cos of 35 degrees plus 45 degrees. Now, that isn't as simple as reading cos 35 and cos 45 off of our log tables. How are we gonna? So, how are we going to do this one? Sorry? We're going to do, we have to find, sorry, 30 and 45, that should be 30, thank you. That should be 30, apologies. Cos of 30 degrees plus 45 degrees. That is one of these angles though. That is a compound angle because we're adding a cos A plus a B. So we must use this formula then. We must use the cos A by cos C minus sin A by sin B formula. So it's a compound formula. So, first things first, my A is equal to 30 degrees and my B is equal to 45 degrees. So in a compound formula, that is equal to the cos of 30 degrees by the cos of 45 degrees minus the sine of 30 degrees by the sine of 45 degrees. And then we use the values from our tables. So what is the cos of 30 degrees? Cos of 30 is root 3 over 2 by the cos of 45, which is one over root 2 minus the sine of 30 degrees is a half by the sine of 45 degrees, which is 1 over root 2. And then multiplication. So, root 3 over 2 by 1 over root 2 into our calculator, or do it in your head, whichever way, is root 3 over 2 root 2 minus a half times 1 over root 2 is 1 over 2 root 2. Straight into your calculator then. Root 3 over 2 root 2 minus 1 over 2 root 2 leaves you with root 6 minus root 2 over 4. Just make sure I did my multiplication there right first of all. Oops, 6/4. It breaks down into a hand-near one, √3/8. So just use your calculator to make sure. Alright. These are slightly off. Just use your calculator to do that multiplication to make sure. √6/4 multiplied by √2/4 is √3/8. Right, let's do another one of these. So, have a go for me. Example number 2 at the sine of 15 degrees. In third form. So what two angles are we going to use to make 15? 45 minus 30 is it? So like 45 minus 30. So that's a compound angle in sine A minus B. One more minute, guys, have a go at that. Look at the last one. Right, guys, let's look at it then. The sine of 15 degrees in third form. So, to get 15 degrees, we're going to say the sine of 45 degrees minus 30 degrees. So that's the sine of A minus B, which is equal to sine A cos B minus cos A sine B. So that is equal to the sine of A, which is 45 degrees, by the cos of B, which is the cos of 30 degrees, minus the cos of 45 degrees by the sine of 30 degrees. So, sine 45 degrees is 1 over root 2 by the cos of 30 degrees, which is root 3 over 2, minus the cos of 45 degrees, which is 1 over root 2 by the sine of 30 degrees, which is a half. So 1 over root 2 multiplied by root root 3 over 2. You're getting root 6 over 4 minus 1 over root 2 by a half, which is root 2 over 4. And take them away from each other. Root 6 minus root 2 over 4. Right, one more of those before we move on. Have a go at this one. Get the tan of 105 degrees. What are we using here? We're going to use 45 and 60. Yeah. Tan of A plus B. Tan of A plus tan of B over 1 minus tan A tan B, yeah? What do we get? 1 plus root 3 over 1 minus root 3. Let's have a look at it. So, that is the tan of, we said, 60 plus 45, which is the tan of A plus B, which is tan A plus tan B over 1 minus tan A by tan B. Wasn't on freeze, be handy. So that is the tan of 60 degrees plus the tan of 45 degrees all over 1 minus the tan of 60 degrees by the tan of 45 degrees. Right, Adam, tan of 60 is what? Root 3 plus tan of 45. 1 over 1 minus tan of 60 is root 3 by 1, which is 1 plus root 3 over 1 minus root 3. We happy with that? Perfect. Right. Jumping on. Next thing. Example 4. So, literally what we're doing today is the hardest thing that comes up in trigonometry. So, the sum and product formula, the compound angle formula. Next week will be grand. It's just 3D problems. They're actually not that bad at all. The sine and cosine rule and how they come up in 3D problems. Today is kind of the tougher stuff. But it leads on from what we did last week. So, A and B are acute angles such that the sine of A is equal to 12 over 13 and the cos of B is equal to 4 over 5. Without evaluating A or B, find the value of the following. Right, what's jumping out there to you? What word should be jumping out there to us? An acute angle, good stuff. So, with trigonometry, you have to first of all determine, are they on about the unit circle or are they on about a right angle triangle? Is that alright? And when you see acute angle, they're on about a right angle triangle. So, there's our A. And the sine of A is equal to 12 over 13. Cos of B is equal to 4 over 5. So, with this one up here, the sine of A is 12 over 13. So, what's the thing for sine? Opposite over hypotenuse. This is 12. This is 13. Get me this angle down here. What's the Pythagorean triple there? Five. Pythagoras' theorem, yeah? Right, this is B. What's the formula for cos? Adjacent over. And you know what the Pythagorean triple is for 5, 4 and 3, exactly. 5, 4 and 3. You know what I mean when I'm saying Pythagorean triple, yeah? As in like they're the 3 ones that give you Pythagoras' theorem. Right, exact numbers. There's a few of them you should be able to whack off the bat. They're 2 common ones that come up. 13, 12 and 5, 5, 4 and 3. Right, so with that in mind, get me the tan of A. Tan of A is, starting off America, 12 over 5. Right, get me cos of A plus B. We use our compound angle formula. This is all using our compound angle formula. No, styrofoam. All the manufacturer styrofoam. Play. No. One more minute to get that done, Dave. This came up in, looking back at the papers, 2016, I think. 2016, 2015. They'll usually show one of these at the top 25 mark question. If you're going to get a trig question, top of the 25 mark or trig question, short question, and then you're going to get a long 3D problem or else graphing. Right, let's have a little look at it. So, the cos of A plus B is, the formula for cos of A plus B is cos A by cos B minus sin A by sin B. So, the cos of A is cot A herring 5/13 multiplied by cos of B cot A herring 4/5 minus the sin of A silly old Harry 12/13 by the sin of B 3/5. Yeah? So 5/13 multiplied by 4/5 is 20/65 minus 3 times 12 is 36/65, which breaks down into minus 16/65. Right, another one of those. Have a go at this one. The sine of 2a. The question is sine of 2a. It's a double angle formula then. Same page, double angle formula. No, you should end up with the same answer if you do it right. I would recommend stay away from the tan ones unless they're looking for tan in the answer, because the tan formulas are generally hard. Any answers, guys? Do you reckon? 120/116? Let's have a little look at it. So, what is my formula for sine 2a? I have two of them on the page in the double angle formulas. I have 2 sine A cos A, or in the bottom right, I have 2 tan A over 1 plus tan squared A. So I'm going to use the easier one, which it looks like there. I'm going to use 2 sine of A by the cos of A. So, my sine of A is equal to silly old Harry. So that's 12/13. My cos of A is cot A herring. So that's 5/13. So the sine of 2a then is 2 times 12/13 by 5/13. Straight into your calculator. (120/169). Okay, guys? Right. Let's change it up a bit again. Still using our compound angle formulas. They want us to show, where is my mouse? There we are. They want us to show the sine of 90 degrees minus A is going to be equal to the cos of A, example number 5. So they want us to show the sine of 90 minus A is equal to the cos of A. So once again, using our compound angle formulas, this is a sine of A minus B. Right. So I'll do this one as an example. Sine of A minus B formula then is, what is the sine of A minus B formula? Sine A cos B by minus cos A sine B, yeah? So the sine of A minus B is the sine of 90 degrees by the cos of A minus the cos of 90 degrees by the sine of A, which is sine of 90 degrees, 1 times cos A minus the cos of 90 degrees, 0 times sine A. That is an answer of cos A, because that knocks out. And there's your answer, there's the proof. Right, what I want you to do for me then is verify the following. Verify the sine of 180 degrees minus A is equal to sine A. Right, guys, let's have a look at it. So that is the sine of A minus B, which is sine A cos B minus cos A sine B. So that is the sine of 180 degrees by the cos of A minus the cos of 180 degrees by the sine of A. Sine of 180 degrees 0 by the cos of A minus the cos of 180 degrees, 1 is it? Minus 1 by the sine of A, that knocks off, minus by minus 1 is plus 1 times the sine of A, which is equal to sine A. You all happy with that? Right. Moving on again. The cos of 2A is equal to 1 over 49. Find two possible values for cos A without evaluating. A. So find two possible values for cos A without evaluating A. So the second thing we did, where we got cos A and then tried to find the likes of sine of A and the cos of A plus B, we're now working backwards. Is that okay? So what is a formula for the cos of 2A? Cos squared A minus? Yeah, so we'll stick to them ones and stay away from the tan ones if at all possible. So the cos of 2A is equal to cos squared A minus sine squared A, and I know that's equal to 1 over 49. Right. So, any idea where I'd go from here? Do you know, like when you're dealing with a load of x's and y's, it's always easier to deal with. All x's are all y's. So it's a bit like trig. When you see cos's squares and sine squares in front of you, it's always easier to deal with. Cos's are sines. Now, there is a tough way and an easier way to do this. If you look in your logbook, you have a cos squared A formula and a sine squared A formula, yeah? Now, the cos squared A formula gives you back something plus cos of 2A. That's not going to be much good to us. And your sine squared A gives you back a half times 1 minus cos of 2A. That will turn everything into cos, but you have a 2A formula in there then, and that just makes life a bit more difficult again. The get out of trouble formula, like there is with most things, like in logs, with the one in the top right corner, is on page 13, top right corner. That one gets you out of more holes than you can imagine on the harder questions. The cos squared A plus sine squared A is equal to 1. Alright, very, very important formula. When you're dug in a hole and you start seeing problems with, especially with cos squares and sine squares, that one is usually going to be your friend. So, the formula is cos squared A plus sine squared A is equal to 1. Now, this can also be written as cos squared A is equal to 1 minus sine squared A, depending on what you want, or it can be written as sine squared A is equal to 1 minus cos squared A. Same formula, written 3 ways, depending on what you want. And as I said, it's kind of your get out of a hole formula for trigonometry. So, I'm going to stick with cos's. So I'm going to change this sine squared A into cos squared A minus times 1 minus cos squared A is equal to 1 over 49. So I've changed out sine squared A and I put in 1 minus cos squared A. Multiplying it out then. Cos squared A minus 1 plus cos squared A is equal to 1 over 49. obviously the reason I'm sticking with costs as well is they want me to get a value for cos of A in the question to make life easier. So that is cos squared A, and cos squared A is 2 cos squared A minus 1 is equal to 1 over 49. Crap. 2 seconds, she's jumping. Two cos squared A minus 1 equals 1 over 49. Right, that's 2 cos squared A is equal to 1 over 49 plus 1, which is 50 over 49. So that then is cos squared A is equal to 50 over 49 divided by 2, which is 25 over 7. Is it? Just double check. 25 over 49, sorry. That's why we double check in the calculator. I mean, able to tell me another way of writing cos squared A. Cos of A to be squared, exactly. Don't forget that. It's an indice rule we learned in algebra. Cos squared A, you can bring the squared out and become cos of A to be squared. 25 over 49, that means cos of A is equal to the square root of 25 over 49, which is A is equal to plus or minus 5 over 7. Sorry, the cos of A is equal to plus 5 over 7 or minus 5 over 7. And there's your two values for cos of A. You can do that the exact same way with tan. The tan rule, the whatever the double angle formula is for tan. It just involves a bit of substitution. Right, what I want you to do, have a go at one of these yourselves. Example number 8. The cos of 2A is equal to 12 over 13. Find two possible values for the tan of A. So we'll all go the same way in this now, just to make sure we don't end up me trying to correct two different ways. So cos of 2A, are we going to go with 1 minus tan squared A over 1 plus tan squared A, or are we going to go with cos squared A minus sin squared A? Leave it up to you. Do it either way. Do I do it the tan way? Something different? Well, I'll do it the tan way, so 1 minus tan squared A over 1 plus tan squared A. So you can do it either way, either formula will be out the way. That's slightly two different methods. As to the tan, probably would. I just don't like using that formula too often. I prefer using the cos squared minus sin squared. But yeah, you can do it either way. This one gets a bit tricky. But what you're saying makes 100% sense. Given it's tan, you should use the tan formula. Tan being on both ways, anyways, just in case you're really fucking home. So we should be left with then, if we're using the tan way, 1 minus tan squared a over 1 plus tan squared a, we're leaving that equal to 12 over 13, because that's what cos 2a has a value. And then we're going to cross multiply. I.e., the word you're not really supposed to say, we're going to cross multiply and then try to work it out from there. So, see what you're doing there, Bill? They'll actually dock your marks in the exam because that's what without evaluating means. I didn't put it in this question, but without evaluating means, it means you can't use the calculator. What you're doing is right, but they don't want you to evaluate anything on your calculator. You want to use it. So you this equals 12 over 13 and then cross multiply. I'd say we're going to do a substitution on this. Fire out from 0 to tan of a equals t. Yeah. So then t squared equals this. These are doing all the substitution for doing with tan. So have a little look at this one maybe. I think it's going to be tough enough doing with tan. So it's important we know how to do them both ways, just in case we are forced. You could be forced to do one of these a certain way, so it's important that we know how to do them both ways. So the cos of 2a is equal to 1 minus tan squared a over 1 plus tan squared a, which is equal to 12 over 13, yeah? So that's 13 times 1 minus tan squared a is equal to 12 times 1 plus tan squared a. 13 times 1 is 13. 13 times minus tan squared a is minus 13 times tan squared a is equal to 12 plus 12 times tan squared a. So that then is 13. Make sure the tan squares are positive anyway. So, yeah, 13 minus 12 is equal to 13 tan squared a plus 12 tan squared a. So 13 minus 12 is 1 is equal to 12 and 13, 25 tan squared a. I'd say you just made a math error and you weren't miles off at all. Divide both sides by 25. 1 over 25 is equal to tan squared a. 1 over 25 is the tan of a to be squared. So that is the square root of 1 over 25 is equal to the tan of a. So that's plus or minus 1 over 5 is the tan of a. So we got away, it wasn't a substitution, just a bit more awkward fraction. Right. Let's have a go at this one. Last one of these where we move on to the different formula. Example number 9. The sine of 2a is equal to 7 over 25, where a is an angle between 0 and pi over 2. Find tan a, sine a, cos a. Pi over 2. So you can use your, this only comes into the brain. So do is normal, which is sine of 2a formula. So compound formula. Everyone got the question to end out? Scroll back up to see you know what I would have done on the last one. We're looking at 2 sine a cos a. It's not going to work for this. You're going to have to go with 2 times the tan a over 1 plus tan squared a, and leave equal to 7 over 25. And do what we did in the last one. As I said, we have to use both formulas, depending on which question pops up in front of you. So leave, what's the formula? Leave 2 tan a over 1 plus tan squared a equal to our fraction, and our fraction is 7 over 25. So leave it equal to 7 over 25, and then work it out like we did worked out the last one. The cross multiplied fractions. What's the problem this time? We're not just dealing with tan squared a, as we also have tan a. So you're more than likely going to have to do a substitution. What I mean by substitution is like we did with the algebra questions, the odd ones. You need the tan a equal to any letter you want to pick, usually the big T. So then the tan squared a would be the tan a 2b squared, which would be b squared. As I say, this is the toughest stuff in trigonometry, so we'll be getting too worried about it. That's why anyone maybe just the three guys we missed because we missed what we did before while we the algebra. But videos are all up there. Go back and look at them because it's so important. Especially what we'll be doing when we use the formulas that we learned in the algebra. So go back and look at them when you get a chance, alright? They're all an hour and a half long. So we made forms right away. Anyway, every week happens. So. Nearly there, guys. 25 minutes left is all. Right, have a little look at it. I think we're all fairly on the same road by the looks of things. Right, so the sine of 2a is equal to 7 over 25. The sine of 2a is equal to 2 tan a over 1 plus tan squared a. And that's equal to 7 over 25, our fraction. So 25 times 2 tan a is 50 times the tan of a is equal to 7 plus 7 tan squared a, yeah? Now, this problem, we have tan squareds and tans. So we're going to have to do a substitution. So the tan of a is equal to t. The tan squared a is equal to the tan of a 2b squared, which is t squared. So that is 50 times t is equal to 7 plus 7 times t squared. So that's 50t is equal to 7 plus 7t squared, which is equal to 7t squared minus 50t plus 7 is equal to 0. Guide number, bracket, bracket, or minus b, whichever way you want to factorize it. Could have some crack here trying to factorize this. Oh, that should be alright. Minus 7 minus 1. 7t is equal to 1. T is equal to 1 over 7. And t is equal to 7. Is that okay? Right. Again, she's jumping. Right. Oh, crap. Stop. Sorry guys, you're after freezing on me. T is equal to 7. So, case 1. There's your triangle. Because at the beginning of the question, they asked us to find tan A, sine A, and cos A. So we said t is equal to tan, so the tan of A is equal to 1 over 7, or the tan of A is equal to 7. There's your angle A. What's our formula for tan? Shorting off America, opposite over adjacent, 1 over 7. What's my hypotenuse going to be? 1 squared plus 7 squared is 50, square root of 50, 5 root 2. So cot a herring, the cos of A is a herring 1 over 5 root 2. And the sine of A, silly old Harry, is 1 over, that should be 7, shouldn't it? 7 over 5 root 2, cot a herring, and 1 over 5 root 2. And obviously tan of A is 1 over 7. Case 2, right angle triangle. There's your A. Trolling off America, 7 over 1. This once again is 5 root 2. It's a horrendous attempt at 5 root 2. Anything that could go wrong now at the moment is going wrong for me. Five root 2. So then the cos of A, cot a herring 1 over 5 root 2, and the tan of A, trolling off, no, sine of A, we have tan of A already, the sine of A, silly old Harry. We all okay with that? Right, that's as tough as they get. Right, let's move on. So example number 10. We're moving on to the sum and product formulas. So example 10. Express the product . Yeah. This here? Yeah. That just means right angle triangles. Sorry, that just means here right angle triangles. Express the product as two trigonometric functions. So the sine of 4 theta plus the sine of 2 theta. So the sum and product angle formulas are on page 15 in our logbook. This is the sine of A plus the sine of B. That should be expressed as the product. So, basically we're turning addition into multiple. Exactly. So this is the sum and we want to express it as a product. So what's our formula for sine A plus sine B? 2 times the sine of A plus B over by the cos of A minus B over 2. Right, off you go. It's literally just inputting figures into our formulas like we've just been doing and picking the right one. So bottom of page 15, yeah? Formula on our logbook. What are we getting? They're going to get us to find exact values. So instead of 4 theta and 2 theta, it's going to be 65 degrees, 50 degrees. So the exact value. It's just that progression. Slightly different. Right, guys, let's have a quick go at it. So, as I said, we're using the formula in the bottom of our logbook 15. So, the sine of A plus the sine of B is 2 times the sine of A plus B over 2 by the cos of A minus B over 2, which is equal to 2 times the sine of 4 theta plus 2 theta over 2 by the cos of 4 theta minus 2 theta over 2, which is equal to 2 times the sine of 6 theta over 2 by the cos of 2 theta over 2, which is equal to 2 sine 3 theta by the cos of theta. Do y'all get that? Good stuff. Right. Working the other way this time. Example 11. Express 2 cos 7 theta by the sine of 6 theta as a sum or difference of 2 functions. So we're going to use the formula above it. We're going the opposite way. We're now going from product back to sum, i.e. we're going from multiplication back to addition and subtraction. So even if you want to maybe write that down in your logbooks, just in case you're a bit unaware. Product to sum means multiplication to addition, and then sum to product means obviously the other way around. Just so you actually have an idea what we actually asked them to do. It's handy. Make a little notes in your logbook. It's handy. Obviously, you can't read your logbook into the exam and give you one there. But you can read the notes if you flip over the page, you know what you're actually doing. So, product to sum means multiplication to addition and subtraction. Yeah, so that's what product means multiply the sum, difference means add and subtract. And this stuff right now. So the difference is the addition. So add and subtract multiplication. Let it look good. See what we get on. So, off our logbook then. 2 cos of 7 theta by the sine. Only 10 minutes left, guys. We're nearly there. Two times the cos of, this is cos A by sine B. So cos A by sine B is the bottom one, yeah? 2 times cos A by sine B is equal to the sine of A plus B minus the sine of A minus B, which is equal to the sine of A, which is 7 theta, plus 6 theta, minus the sine of A, which is 7 theta, minus 6 theta, which is equal to the sine of 13 theta minus the sine of theta, which works out being the sine of 12 theta. Right. That is more of an introduction. How would this pop up in an exam? Probably the last thing we're going to get around to today. Find the exact value of the sine of 75 degrees minus the sine of 15 degrees. So we're using the ones on the top or the ones on the bottom? The ones on the bottom, exactly. We're going from subtraction back to multiplication. So we're going to go with the sine A minus the sine B. Again. Root 2 over 2. 0. Root 2 over 2. Stop that. Small mistake, one of I said. Right. So, the sign of A minus, just to let you know, lads, you've covered about two and a bit weeks of work that you normally do in school in the class, like, so you're absolutely flying it. Generally, you do this over about 2 weeks. Because that's about 12 pages of a trigonometry chapter. So you're absolutely flying it. Sine A minus sine B. So that's 2 times the sine of A plus B over 2 by the cos of A minus B over 2, which is 2 times the sine of A, which is 75 degrees, plus 15 degrees over 2 by the cos of 75 degrees minus 15 degrees over 2, which is 2 times the sine of 75 plus 15 is 90 over 2, which is 45 degrees, by the cos of 60 degrees divided by 2, which is 30. That is 2 times the sine of 45 is 1 over root 2 by the cos of 30 degrees, which is root 3 over 2. Did I use the wrong formula?
No, just swap the sine and the cos. So it's 2 cos A plus B over 2.
Sorry, sine A minus 2 cos. Oh, 2 cos.
And then sine.
Yeah, thanks very much. I read the wrong formula off the book. Cos, sine, cos, sine. Cos of 45 degrees, so then is 1 over root 2. And then the sine of 30 degrees is a half, is it? So that is 2 over 2 root 2. Is that what you said? 2 over 2 root 2. Right, guys, we'll leave it there for today. That okay? So, what are we going to get on to next day? We're going to get on to the proofs, 1 or 2 of proving, and the next day we're also going to look at the 360 degree tougher ones that we were doing earlier on today that we started with. These kind of ones, except in the 360 degree, not the 90 degree right angle. And we'll do a bit of cosine and sine. Probably we're only going to be able to get around to integration the last week instead of the last 2 weeks, but don't worry, obviously moving on a week into after Christmas. Also, last thing before you go, the last week of this, the Saturday the 14th, I'm caught with a trip with the school, which I can't get out of, i.e. a charge thing on Saturday morning. Are you okay to do it Thursday evening, 7 to 8:30? Is that a problem? Thursday, 2 seconds. Thursday is the 19th. Thursday 19th, 7 to 8:30. We all okay? Right. Just to let you know that, right? So instead of the Saturday morning, it's going to be Thursday Thursday the 12th. Yeah, Saturday 14th. Thursday the 12th from 7 to 8:30. Thanks, guys. And I'll see you next week, alright? See you next Saturday. Sorry? No, the study's just down here in the bottom hall. So take yourself a 10-minute break, get a breath of fresh air. And you can stay here. This probably easier to move you all again. Yeah, just tell you, man, come on. This room's warmer now. Study. Yeah, you can stay here for study.